My name is Rodrigo Hamede. I'm a postdoctoral research fellow at the School of Biological Sciences at the University of Tasmania. And for the last 10 years or so, I've been working on disease ecology-related projects. And most of my time these days is dedicated to study Tasmanian devils and facial tumors.
Our planet Earth, a world of mystery and imagination, science and wonder that is constantly being gazed upon and unraveled by the finest minds humanity has to offer. Welcome to the UniV podcast, the show that presents a free-flowing conversation with those beings at the very center of the world of academia and research from all around the globe, with your host, Simon Holland.
The Tasmanian Devil, a rare creature with a mythically ferocious temper made famous through the animated series Looney Tunes. The real Tassie Devil is unfortunately under threat from a rare type of cancer eating through the tiny and remote population still existence in Tasmania, Australia. Hello and welcome to episode 11 of the UniV podcast. Today we talk to Dr. Rodrigo Hamede, an ecologist specialising in infectious diseases who is attacking this aggressive form of virulent cancer known as DFTD. Without further ado, we welcome Dr. Hamede to the show. Tasmanian Devils is a very niche community of animals, a long way from home. How did you manage to find yourself over here studying that?
Well, actually I'm from Chile originally, so I came to Tasmania for doing some bushwalks because, Tasmania is one of the best places in the world for doing bushwalking. And I was always a keen bushwalker and always a keen person in terms of following nice wildlife. So I came here for 3 months to do a few bushwalks with the hope of seeing a wild Tasmanian devil, which I did. And then I decided to go back to university because I'm actually, my degree is in linguistics and Spanish, so I'd never studied science before coming to Australia. So I went back to university and did a degree in science and environmental sciences. And then after that, I met Mena Jones, who was working with Tasmanian Devils, and I did my thesis on Tasmanian devil behavior. And then I applied for a scholarship for doing a PhD. I did my PhD, and I'm doing a postdoc. So one thing led to the other, and I'm still here watching Tasmanian Devils, which is quite fun.
And when you started, what was the state of the Tasmanian devil population? Was there, because they had a few issues, didn't they?
Yeah. When I got into Australia in 1999, 17 years ago, there were lots of Tasmanian devils. In fact, sadly, the first dozen of Tasmanian devils that I saw were actually roadkill on the highway when I was traveling from one place to the other in Tasmania just to go to national parks and, try to pitch my tent in the evening in a place where I could hopefully see a wild Tasmanian devil. So it was quite easy to see them in the road. These days, you hardly ever see a devil in the road because there's not many. But the population was a lot healthier. There was plenty of animals around, and unfortunately, in a matter of 10 years or so, we lost 70 to 80% of the state population of Tasmanian devils, which is striking. And as a result, devils were listed as endangered.
And what was the cause of that, the loss?
Mainly devil facial tumor disease, and when I say mainly, I mean 99%, because road mortality has always been in Tasmania since we have vehicles in the roads. Tasmania is probably the worst state in Australia and for roadkill, but the species are so abundant that they actually do nothing to population dynamics. So you don't have an increase or a decrease in the species abundance or density because of roadkill. But this disease basically kills animals in a matter of 6 months after the tumors appear, 6 to 9 months. And in a very short period of time starts to infecting pretty much almost throughout Tasmania. And it's because devils love biting each other. And that's part of devil business. It's part of their behavior. And this disease is transmitted by biting. So this tumor formed the perfect host with the perfect behavior for jumping from individual to individual. And as a result, we lost 80% of devil populations specifically with this disease, which is really rare. Diseases usually are not the single cause of population decline. There's a combination of factors. But in this case, we're pretty certain that the DFTD is the reason why we've lost so many devils.
And what is it about the disease that makes it so dangerous?
Well, it's cancer. So it can't get worse than that. We know what cancer does to humans and to pets and to wildlife. Cancer is a very common disease in vertebrates. It's not just unique to humans or to your pet dog or your pet cat. It occurs in pretty much every species and every vertebrate species. And there's no cure for it, and it's 100% lethal. So it is really bad. However, why cancer has never been a problem for conservation biologists? Because they're not infectious. They're not transmissible. The tumor arrives within an individual, and that individual dies with the tumor, and the tumor dies. This cancer is very, very special. In fact, it's only one of the 3 transmissible cancers that we know of, in the sense that it can be transmitted from individual to individual as an infectious disease, as you would catch another kind of infection. So that is why this disease has caused these dramatic population effects in Tasmanian devils.
Is it particularly dangerous because the Tasmanian devil is a specialised creature unique to this part of the world?
No, the disease is on itself is dangerous because it is a transmissible cancer. So it would be as dangerous to any species that has this type of disease. The problem with Tasmanian devils is they're endemic to Tasmania, so they only occur here. So losing Tasmanian devils in Tasmania means losing Tasmanian devils around the world. Losing the species, it means an extinction of the species. But also it means the loss of a top predator of an ecosystem, because the Tasmanian devil, after the extinction of the thylacine, became the top predator of Tasmania, and as such fulfills a very important ecological role within the Tasmanian ecosystem. So losing a top predator has cascading effects for the entire ecosystem. So it's a magnified problem.
And so what have you guys been doing there in terms of research to try and, first of all, understand the cancer and second of all, attack it?
Absolutely. The first step was to realize, actually, after probably 6 to 7 years, and took us to realize when this disease was reported for the first time in 1996 in the northeast part of Tasmania, but it was just a photograph from a wildlife photographer with a devil with massive tumors around the head and neck, and just like, oh my God, this devil has cancer. But it wasn't until it has deformations or tumors or ulcers or some weird thing around his face, because it's a quite bizarre disease. I mean, it disfigures the animals. Tumors grow quite fast, and they look horrible. So it's impossible to me not to realize that something is wrong with the animal. But it wasn't until 2001 that we start seeing these kind of tumors more often in the eastern part of Tasmania, around Freycinet, where Mena Jones were undertaking her studies on Tasmanian devils. And it was 1, 2, 3, 4, 5 cases, and we start thinking, they look very similar. What's going on here? And by 2006, Anne-Marie Pearce and Kate Swift published her paper on Nature, and we had evidence that this, in fact, was a transmissible cancer, that it was the same tumor from the original devil that developed this tumor that has been passed on from individual to individual since then. So that was the starting point of the Save the Tasmanian Devil program, and from the government of Tasmania and a large research group at University of Tasmania and other international organizations to start understanding this new transmissible cancer. As I said, the only other known transmissible cancer is in domestic dogs, the canine transmissible venereal sarcoma, which is a sexually transmitted tumor that is 11,000 years old and arose in wild canids, and it was passed on to dogs, and since then has been evolving with this host, and these days it's a lot easier to treat in domestic dogs with chemotherapy. So it's a new type of disease. It's a new conservation challenge, and therefore we needed to start from zero, pretty much knowing nothing about it. And though 20 years have passed since we had that photo with the devil with a tumor, it seems a lot of time, but from the point of view of learning from an emerging infectious disease, an emerging transmissible cancer, it's not a lot of time.
Is it something that, as an ecologist, did you fear, because it moves so quickly and evolves so quickly? Is it something that you're like, we might not be able to research this in time to save this population?
That has been our biggest fear. And in fact, a few years ago, 5 or 6 years ago, we did some predictive models. At the rate that populations were declining, local extinctions were likely to appear 7 to 10 years after disease emergence in the local population. And we predicted within 30 to 50 years we could lose the entire species. And of course, the devil and the tumor are playing catch-ups, because as you know, with any infectious disease, including infectious diseases in humans, the host and the pathogen start to this kind of evolutionary race to start adapting to each other. So while the host becomes much better in coping with the disease is evolving to become more transmissible and to be able to persist in the population. So the tumor is another species, if you want to think it like that. And from the tumor perspective, they need to be transmitted to other devils so they can keep replicating. So our fears were that if things were steady, if the rate of the decline was steady, we could lose the devils in a short period of time. And the good news that came a few years later, only recently in the last 2 to 3 years or so, we started to see slight indications, the very beginning indication that devils are getting better at coping with this disease, and they're evolving to, I wouldn't say to eliminate the disease at all, because it's unlikely that this disease will disappear from Tasmania, but at least to cope a little bit better with it and be able to become sustainable in time, although we are still at 20-25% carrying capacity of Tasmanian devils in Tasmania.
Is it the Tasmanian devil's behaviour that's changing, or is this a process of natural selection, or how's this work?
Yeah, that's a very interesting question, and I always wished that Tasmanian devil behaviour would change. Because of natural selection, the animals would reduce. Aggression levels would be the ones that don't catch the disease, therefore the ones that breed, and those genes will pass on into the next generation, and selection would occur. So that was, as a person, very interested in animal behavior, and that was the reason I started studying devils 10 or 12 years ago. I thought that would be the case, but unfortunately devils can't help themselves, and biting is like we talk, they bite, and especially during the mating season, which is quite aggressive. Copulation itself is quite aggressive. Males subdue females into dens and guard them until they're receptive, so these animals stop feeding for weeks, and mood gets really not necessarily nice, and the females are not receptive, and devils try to mate, and there's a lot of fighting until they're finally receptive and they mate. But those 2 weeks of mate guarding, they just have a huge effect in terms of biting injuries that animals inflict to each other, and that's when also the disease is passed on. So they haven't changed their behavior in that sense, but they have been evolving at a genomic level, and this is a study we just published a couple of months ago or a month ago in Nature Communications that shows that there's selection at regions that are associated with immune response and cancer genes in the genome of the devil in populations that have been subject to DFTD for more than 10 years. And that means that hopefully in the future, devils will start reacting a little bit better to this disease and will be able to somehow do something about it, either survive more with the disease and increase their tolerance to infection, or fight back their disease and increase their resistance to infection. And this tumor is transmissible because it's invisible to the immune system of the devil. And that's why they cannot reject cancer cells from other individuals. Because, if I had cancer or any species had cancer and you pass those cancer genes to another individual, your immune system now, okay, this is not my cells, these are cells from another individual, so the immune system attacks it, end of the story. But this tumor downregulates the immune response of the devil, the tumor itself, so it becomes invisible to the devil, and the devil doesn't know that those cells from other individuals thinks it's their own cells, and therefore the immune system is not activated and doesn't respond to it. So we had some indications that if this was the case and evolution was occurring in these regions, immune regions of the genome of the devil, maybe in the future some devils will start recognizing these tumor cells and reacting to it. And that's exactly what we found last week in the new study that we published a few days ago.
Tell us a little bit about that study with the results.
Well, this is a population that I've been monitoring in the northwestern part of Tasmania since the beginning of the epidemic outbreak in 2006. So it's been 10 years. Every 3 months for the last 10 years, I've been going to the same population for 12 days, put 40 traps in a 25 square kilometer area, and monitor the infection status, take blood samples and a number of different biological samples and a basic population ecological epidemiological study. So there's a long-term commitment that I've had in this population. And for the first time, we've seen a handful of animals, 6 of them, that they've actually had anti-DFTD response. That means that the immune system saw and was activated when they were infected with DFTD. So in other words, these are the first 6 individuals for which DFTD is not invisible to the immune system, which is what we would have thought that it could happen in an evolutionary timescale. We're talking about hundreds of years rather than 20 years since disease arrival. So it is a striking evolutionary response. It is absolutely striking and sensational that animals were able to do that in such a short period of time. But the selective pressure of the disease is so strong that, devils have no choice but to start to reacting now, or their numbers are going to become so low that extinction is going to be a possibility.
And that's the fascinating.
And out of those, out of those 6 devils that show immune responses, 4 of them had tumors, because if they had immune responses, all that we know is that infection occurred, but we don't know whether they developed tumors. 4 of those 6 devils, I actually got them with tumors. And then 3 and 6 months later, when I came back, they didn't have tumors. So 4 of these 6 devils that managed to see DFTD, immunologically speaking, were able to cure themselves from cancer, which again, it is a striking response, and it is such a fascinating response. It is a tiny proportion of the population. 6 and 4 out of those 6 were able to fight back the tumors and be completely healthy out of more than 170 that I've had with disease. So it is a very tiny proportion of the population, but it is the beginning of something. And we don't expect this to happen from, one day to the other in 100% of the infected population. We expect that this is going to be a very slow evolutionary race between the devil and the tumor, but at least we have the raw material now. We have evidence that some animals are able to do that.
If you were to hypothesize, how do you think that the immune system's treating the tumors in those 4 individuals?
That is the big question, and we've been working with immunologists from the Menzies Research Institute at the University of Tasmania with Professor Greg Woods and Ruth Pye, which is a PhD student that was the first author on this paper. And we have evidence that these immune response occurred and that tumor regressions resulted at the same time that the immune response occurred. But we don't know the exact mechanisms of these immune response and tumor regressions. And this is the next phase of our study. We're going to try to understand whether this is driven by the immune system of the devil or it's driven by changes in the tumor genome. There's a lot more to learn about the genome of the tumor, and not just the devil, because the tumor is another species and is also evolving. So to further understand the exact mechanisms of tumor regression, we're going to need a lot more work.
Now, this is the big question that I've been thinking this whole time, and I'm sure a lot of the listeners have been thinking too. Is this type of disease, something we could see that could generate in humans? This style of disease, I guess?
Well, it is difficult. There are infectious cancers which are transmitted by viral agents, papillomavirus and other cancers that affect humans and wildlife. But this is not the tumor itself directly jumping into one species. There is a viral agent and an oncogene that is involved in that transmission. Transmissible cancers, on the other hand, is just a clonal tumor. It's the same tumor cell that from individual patient 0 is still surviving. In that sense, the transmissible cancer in the dogs is the oldest living cell line in the world. For 11,000 years, that cell line has been jumping from dog to dog.
Wow.
It would be extremely unusual to see this in humans. However, it has been reported in a case where a doctor was removing a tumor from a patient and it cut himself, I think, and a few weeks or months after the operation had this tumor in his hand, and the tumor was obviously genotype, and it was exactly the same tumor that the patient had when he did the surgery. Somehow this tumor managed to grow in the doctor, but it was just removed and treated, and it didn't end up in a situation that compromised the life of the doctor that did the surgery. But it proves, bizarrely, that one tumor from patient 1 can be implanted in another tumor from patient 2. However, I suspect that if that happens, it will never trigger an epidemic like we're seeing in Tasmanian devils. 1, because we're not doing surgeries to each other at the same rate devils are biting to each other. And 2, because hopefully we won't learn to bite to each other either.
Yeah, I was thinking that the whole time.
So it would be, unless there is a viral gene, a viral agent in the transmission of the tumor, I doubt that this is going to be a problem for humans or for other species, because there's a lot of other species in Tasmania that people have been hypothesizing. Maybe this disease will jump into quolls. It would be striking because this is a devil cell, a devil tumor cell, that would have to be completely invisible to another species, to a quoll species, and although they're related, I wouldn't say it's impossible, because I think I've learned that in biology nothing is impossible, but I would say it is extremely unlikely that that could occur.
Now, what was it about the Tasmanian devil initially that got you involved?
I love top predators. My dream species to work with were I feel it's cats, wild cats. There are no wild cats in Tasmania. There are only feral cats, which are a tremendous problem for conservation and for keeping the ecosystem of Tasmania balanced. And Tasmanian devils, in fact, are the best suppressors of feral cats. So when devils were very abundant, feral cats were not as abundant, because direct competition resulted in feral cats being suppressed somehow by the devil. And sadly, the demise of the devil has coincided with a big increase in number of feral cats. So I've always been charmed by top predators, by wildlife, and weird ones, the ones that are not very common. And coming from Chile, going to Tasmania, to the other end of the world. So I used to think that Chile was the end of the world. Now that I'm in Tasmania, I think there's 2 ends of the world. To see these iconic, endemic, weird species was kind of a good thing to do for a holiday. And then just working with them, they're just the most incredible docile animals to work with. I just got absolutely in love with them. And then I decided to change my career and dedicate my time studying them.
And how do you think, have you got support from around the world, or is this something that's so specific? I mean, there's a lot of mythology, Tasmanian Devils. There was the animated series, the Tasmania.
Yeah.
Is it
they look nothing like that.
No.
Yeah, I love what you say. They look nothing like that. This is one of the only carnivores in the world that you can work, trap, take blood samples, open their mouth, take tumor biopsies, take ear biopsies, do anything you want to do without a single drop of sedation or anesthetics. All you have to do is put them in a sack, blind their sight, and they just sit on your lap as your cat will sit, and you can do even easier than handling your pet cat is handling a Tasmanian devil. They are the most docile animal. It's bizarre because carnivores don't behave like that. But devils have this kind of freeze behavior, and they let you do whatever you want. They let you open their mouths, flick their tongues, look at their teeth, put needles, put biopsies on them, and they just do absolutely nothing. They're the most cooperative species that you can work with. So I feel very lucky to work with a species like that, because it makes our life a little bit easier. But in terms of cooperation and research, we now work with institutions around the world. In fact, this study, the evolution at the genomic level, was done in conjunction with Washington State University and Idaho University, which we have a National Science Foundation grant for the ecology of infectious diseases with the United States that has been sponsoring my work here at the University of Tasmania for the last 3 years. We work with aspects of the Sanger Institute, one of the best institutes for human medical health and cancer research in the world, and the University of Cambridge, University of Southampton, half a dozen universities around Australia. We have a multidisciplinary team of international scientists around the world working on this, because it's just not one area of research. My area of research is disease ecology and epidemiology, but this involves immunology, involves cancer biology, involves therapeutic treatment, includes modeling, genomic analysis of samples. So it is a very cross-discipline international research team that is trying to understand evolution in situ and real ecological timescale. This is happening in our eyes, right in front of us at this time. So it is a fascinating system to work with, though it is a very terrible system because it's doing terrible things to Tasmanian devils. But from the point of view of seeing how an emerging cancer evolves in a population of endemic species, it is absolutely fascinating.
Now, this is a very tough call, but can you predict, or do you think, what do you think is going to happen from here on out?
If you would ask me that question 5 years ago, I would have answered you a question that would have been a lot more negative about it. I think in the light of our recent results, I think, first of all, extinction in the short term looks unlikely, very unlikely, in fact. Eradication of the disease in Tasmania, it's not possible, it's not feasible. So it looks like coexistence is going to happen in the next 5 to 10 years between devils and tumors. And when I say coexistence, it means a little bit of more trade-offs, a little bit of more cost and benefits of some animals developing resistance to the FTD. But that means that the tumor also has to be evolved to become better at transmitting disease, because if it's not transmitting disease enough, then the tumor itself is at risk of extinction. But if the tumor is running out of hosts and killing all the devils, it's also driving itself to extinction. So I think the outcome of this host and pathogen devil tumor interaction is going to be coexistence or coevolution. How long it will take, I don't know. I wouldn't give a time frame because these things are very difficult to predict. And just to put another fact into the equation, last year we found DFTD2, a second independently evolved transmissible cancer, another type of transmissible cancer that is not DFTD, though it looks the same. It is absolutely different and evolved independently, and is only localized at the moment in southeastern Tasmania, and we're trying to learn a little bit more about that tumor that we know of only a year ago. So, in other words, we know nothing about this second transmissible cancer in Tasmanian devils. Everything that we've been studying and everything we've been talking about so far in this conversation is about DFTD1. DFTD2 is a black box, and we don't know what kind of impact it's going to have in devil populations in the long term because we know hardly anything about it.
Wow. Dr. Hamede, that sounds like you have quite a battle on your hands. If people would like to get involved or show support or follow along with your research publications, what's the best way to get involved?
Well, there's several ways to get involved. There is a website called the Save the Tasmanian Devil program, which is very comprehensive. You can find a lot of publications, a lot of different management strategies that the government is doing and different research projects that university is doing. And very important, there is a donation button that you must click. And once a year, the Save the Tasmanian Devil Appeal gives research grants to universities around the world to do Tasmanian devil research. So that's a very important thing, that if anyone is interested in helping, every dollar, even if it's a small donation, even if it's a $1 donation, it is another dollar that goes 100% to research. It's not used for anything that is just applied research. Something that is a little bit more fun, if they go to the website of the University of Tasmania, and you will find a link to volunteering with Tasmanian Devils. As I said before, I go to the field every 3 months, every year, and I have half a dozen students doing field work. And we always need help in the field. If people are really keen to come to Tasmania and give us a little bit of a hand in the field, collecting data, taking biological samples, etc., we take not just students, but we take any member of the public that is interested into the field to see in real life how we're doing science with this beautiful animal.
Fantastic. And that sounds like a fantastic strategy for the Australian science community and also people traveling, backpackers, anyone who comes through, such as
Absolutely.
Yourself, just like yourself.
Yeah, we got a lot of backpackers. Yeah, it's funny because I'm now taking a lot of backpackers, some of them from Chile, which is quite ironic.
Yeah, that's perfect. Well, thank you very much for being on the show, and we'll chat to you soon, no doubt.
My pleasure. See you soon.
And catch up.
Cheers.
Well, that's all we have time for. If you like what you heard on this episode of the Univie podcast, please leave your thoughts and a rating on iTunes to improve the standing in the algorithm and help get this information out there. These are the rock stars of discovery after all. Bye for now.
Well, that's all we have time for this week. Thank you for listening to the Univie podcast. To follow our series, please subscribe to our channel via iTunes, Beyond Pod, or the equivalent service. And if you particularly enjoyed the show, Please don't forget to rate. For further information, news, videos and articles, head to univ.com.au.